Hello everyone. In this video we'll learn how to solve trigonometric equations. So when it comes to trigonometric equations like sine x, like sine or cosine maybe, we're talking about the length of each period is 2 pi. So the function itself repeats itself every 2 pi. And the domain is all real numbers. Same with the cosine function. From both sides, right? And so on. So for example, if I'm talking about sine x equal 1/2, 1/2 is somewhere here, right? So if I'm talking about sine x equal 1/2, I'm talking about all these values goes forever to the infinity and negative infinity. So we're talking about this angle, this one, and this one. So we do have an infinite number of solutions. Same if I'm talking about cosine x equal 1/2. I'm talking about this angle here, here, here. If you notice, for each period from here to 2 pi, each 1/2, if y equal 1/2, I have two values, two x values for one period, and then it comes again in the second period, and so on. Same with the cosine, so 1, 2, then 1, 2, and so on. Therefore, for any angle, any solution in the sine or cosine, since the period length is 2 pi, we will add and subtract 2 pi for each solution. Okay, and we're going to talk about this in more details. Now, when it comes to tangent, the length of the period for the tangent is pi, not 2 pi. So every pi, the function repeats itself. So in this case, we're going to add pi or subtract pi each time. Now, sometimes in some questions, they will decide what the period that they want you to give the answers over. So in this case, we are going to only do 0 to 2 pi. However, I'm going to explain, if the question did not mention 0 to 2 pi, how to write the general solution. Let's do this one, sine theta equal 1/2. We need to read out of sine, and the only way to read out of sine is to take the inverse function. So the inverse function cancel the original function, because sine inverse of sine x equal to x. Okay. Same with cosine inverse and tangent inverse. Basically, and cosecant inverse and so on, because these two will cross out each other and x will left. So in this case, in order to find this question here, to solve it, we need to take sine inverse of both sides. Now remember, if I have theta, I'm going to have two solutions. So we need to look for two solutions. So theta will be equal sine inverse of 1/2. And by using the calculator, this is going to be pi over 6. In degrees, that's 30 degrees. Guys, remember, if the question gave you the interval in pi radian, you have to write your solution in radian. Now we are not done. We need to ask ourselves when sine is positive, because 1/2 is a positive, right? So we need to ask ourselves when sine is positive. Well, based on the cast rule, sine is positive in a quadrant 1 and in a quadrant 2. Now in a quadrant 1, we already got it, because this is an angle in a quadrant 1. So theta is going to be pi over 6. So theta in a quadrant 1. And also theta in a quadrant 2, that's theta. I need to find the angle measurement in a quadrant 2. Well, in order to find it, we need to find this angle here first. This is called a reference angle. We need to find the reference angle. The reference angle here will be the same as this one, because this is also a reference angle. So it's an angle less than acute angle less than 90, closer to the x-axis. So we're going to say it's pi minus the reference angle. So we're going to be pi minus pi over 6. You can calculate this, make this equal to 6, and here we will multiply by 6, common denominators. 6 minus 1 is 5. 5 pi over 6 in degrees is 150 degree. So I have 30 degree and 150 degree. If you want to check your answer, you take the calculator, put sine 30 or sine pi over 6, it will get 1/2. Sine 5 pi over 6, you will get 150. So you have two solutions. My solution is pi over 6 and 5 pi over 6. Now that's if I want only two solutions from 0 to 2 pi. However, if you want a general solution, then you will say, okay, it's not pi over 6, it's theta equal pi over 6 plus or minus 2 pi n or 2 pi k, sometimes they use. Here you will say theta equal 5 pi over 6 plus or minus 2 pi, again n or k. N is basically a number, an integer from 0 to infinity. So if you take n 0, 0 times 2 pi is 0, so the answer is pi over 6. If you take n is 1, then 2 pi times 1 is 2 pi, so the answer will be pi over 6 plus 2 pi, or pi over 6 minus 2 pi. So we make it, because it's an infinite number of solutions, so we keep it open. So instead of saying 2 pi and then plus 4 pi plus 6 pi and so 5 and so on, you will say 2 pi n. Just very quickly again, I will go back to this point here, the two solutions. If I'm talking about 0 to 2 pi and 1/2 somewhere here, we're talking about this angle and this angle. This is pi over 6, and this one would be 5 pi over 6. Sine 2 theta equal 1/2. Well, in the previous question, we were asking about theta from 0 to 2 pi. Now, I want 2 theta here, and 2 theta will be from 0 to, when you multiply everything by 2, we'll get 4 pi. When I see 2 theta, that means I'm expecting to have 4 solutions, not 2 solutions. So doing the same as what we have done before. So for example, first of all, if I'm drawing the theta, this is 2 pi, and here's another 2 pi. So we're talking about 4 pi, okay? So 1/2 is here. We're talking about this one, this one, this one, and this one, okay? So we're talking about 1, 2, 3, 4 solution within 0 to 4 pi, okay? That's what we are looking for. Now, what we are going to do here, we will take an inverse for both sides. So 2 theta will be sine inverse of 1/2. That's equal to pi over 6. We have done the same, so I'm going to just repeat it. So we need to ask ourselves when theta is positive. So we know theta is positive in quadrant 1 and 2. And in quadrant 1, we are talking about this angle, which is basically pi over 6. And here we are talking about, as we mentioned in the previous question, it will be 5 pi over 6. But now we are not going to say theta, we are going to say 2 theta. Pi over 6, 2 theta equal 5 pi over 6. Now we need to rid out of the 2. So theta equal pi over 12. Divide by 2. Theta equal 5 pi over 12. So that's my first solution for theta. That's my second solution. Now what about the other ones? Well, the other ones, I'm going to go here and add 2 pi. Again, I'm adding 2 pi. I'm not subtracting 2 pi because we are talking about the positive side. Same here. 5 pi over 6 plus 2 pi. And then you do the calculation. I'm going to have 6 down, so I will multiply by 6. 12 plus 1 is 13 pi, so 2 theta equal 13 pi over 6. And then you will divide both by 2. So theta is equal to 13 pi over 12. So that's my third solution. Finally, I'm going to do here same thing. I'm going to make this 6, so I'll multiply by 6. So that's going to be equal to 2 theta equal 12 plus 5, 17 pi over 6, and then you will divide both sides by 2. So my solution, theta equals 17 pi over 12. It's my fourth solution. Now I need to ask myself, are all these angles within the interval 0 to 2 pi? Because we at the end of the day, we are calculating theta, not 2 theta. Yes, because this is an angle in a quadrant. This is an angle less than 2 pi, 360. This is 13 pi over 12 is basically 195 degree, so less than 360. 5 pi over 12 is less than 360. And 17 pi over 12 is basically less than 260. It's 255 degree. So we have 4 solutions. Now I'm talking about sine theta over 2 equal 1/2. Well, again, theta is between 0 to 2 pi. And when I ask about theta over 2, I'm expecting to divide everything by 2, which is pi. Now we are going to follow the same steps by taking sine inverse of both sides. So theta over 2 will be equal sine inverse of 1/2. And that's again pi over 6. Now we need to ask ourselves, sine is positive in quadrant 1 and quadrant 2. So theta over 2 will be pi over 6. Theta over 2 will be 5 pi over 6. Now I will multiply by 2. That's going to be theta equal pi over 3. Multiply by 2. Theta equal 5 pi over 3. Now, let's just quickly think about it here. Pi over 3 is 60 degree. And this is an angle less than 360. So that's one solution. 5 pi over 3 is 300 degree. So it's still an angle less than 2 pi. Now, let's try to add 2 pi each time now. So I'm going to take this and add 2 pi. So theta over 2 equal pi over 6 plus 2 pi. And that's basically equal theta over 2 equal 13 pi over 6. And when you multiply by 2 both sides, you will get theta equal 13 pi over 3. 13 pi over 3 is actually 790 degree. That's an angle greater than 360. So we are not going to take this angle. So how many solutions do I have? Even if you try, by the way, this one, theta over 2 equal 5 pi over 6 plus 2 pi, you will get an angle greater than 360, so you are not going to take it. So I do have 2 solutions, pi over 3 and 5 pi over 3. Now what about this question here? 3 sine theta plus 1 equals sine theta. We need to move signs to one side and the number to the other side. So 3 sine theta minus sine theta equal -1. 3 minus 1 is 2 sine theta equal -1. And then you will divide both sides by 2. So sine theta will equal to -1/2. You will take sine inverse to both sides. So theta is going to be equal sine inverse of -1/2. And this, by using the calculator, will be -pi over 6. Now remember, theta is between 0 to 2 pi. This is a negative solution, so we're not going to take it, right? So what we're going to do, we need to ask ourselves, when sine is negative? Well, sine is negative in 2 places, in quadrant 3 and quadrant 4. So an angle in quadrant 3, we are talking about this angle here, from here all the way to here, an angle less than 270 and greater than 180, and an angle here less than 360. Now, how we are going to find this angle? Well, in order to find the angle here, we need to know the reference angle. Same with this one. I need to know the reference angle. So theta basically will be equal pi plus the reference angle. Here theta will be equal 2 pi minus the reference angle. Now, what is reference angle? Reference angle is this angle because this is an angle less than 90 degrees. That's an acute angle. Forget about the negative side and sign. So that's going to be my reference angle because pi over 6 is 30 degrees. I'm going to say theta equal pi plus pi over 6. Forget about the sign, okay? Which is going to be 7 pi over 6. Here it will be 2 pi minus pi over 6, which is going to be 13 pi over 6. So now we have two solutions here. We have 7 pi over 6 and 13 pi over 6. So my solution set, 7 pi over 6, comma 13 pi over 6. Now, if he wants the general solution, he will say, okay, the solution is going to be 7 pi over 6 plus or minus 2 pi n, or 13 pi over 6 plus or minus 2 pi n. Okay, based on the question. Okay, next question here. We are doing exact same thing again. So I'm going to move the sign, negative sine theta to the other side. So I'm going to have sine theta plus sine theta equal negative square root of 2 sine theta, negative square root of 2, divide both sides by 2, sine theta will equal negative square root of 2 over 2. Now you can take sine inverse for both sides. So theta is going to be a sine inverse of negative square root of 2 over 2. You can use the calculator to find the answer, and the answer for this will be negative pi over 4. Negative pi over 4 is negative 45 degrees. So it's an acute angle if you forget the negative sign. So this is not solution, because again we are looking at a solution from 0 to 2 pi. Negative pi over 4 does not belong to 0 to 2 pi. We need to ask ourselves when sine is negative. So sine is negative again, two quadrants. In a quadrant 3 and 4. Okay, so theta in a quadrant 3 and theta in a quadrant 4. Now, what about this? How we are going to use this one? Well, this is a reference angle, pi over 4, pi over 4. Now, theta will be equal to pi plus pi over 4. You can multiply here by 4 to make it like denominators. That's going to be 5 pi over 4. You can do it in your calculator. I'm just doing it without. And here, theta will be equal to 2 pi minus pi over 4. And that's going to be equal to, again, I want this to be 4, so this is going to be 8. 8 minus 1 is 7 pi over 4. So I have two solutions, 5 pi over 4 and 7 pi over 4. And if we did not specify from 0 to 2 pi, you will say 5 pi over 4 plus or minus 2 pi n, or 7 pi over 4 plus or minus 2 pi n. One more time, n is a number. If it is 0, then you are taking only these two. If it is 1, then you will take this plus 2 pi or minus 2 pi, and so on. Okay. Now, 2 cosine theta plus 1 equal to 0. Okay. In this case, what we are going to do, I'm going to move the 1, divide both sides by 2, and now we want theta, so I'm going to take cosine inverse for both sides. So theta is going to be equal cosine inverse of -1/2. Cosine inverse of -1/2, if you use the calculator, is 2 pi over 3. 2 pi over 3 is a positive angle. It's in quadrant 2. Quadrant 2. So let's try to find out when cosine is negative, to see if we are going to take this angle or not. Well, cosine is negative in a quadrant based on cast rule in quadrant 2 and in quadrant 3. So theta in quadrant 3. Now, in quadrant 2, we already got an angle, which is this one. So theta is 2 pi over 3. We don't need to do anything else. Now I need to know an angle in quadrant 2. Well, an angle in quadrant 2 basically is pi plus the reference angle. So theta should be equal to pi plus a reference angle. Reference angle, I don't know it. I need to find the reference angle. I can tell it from here, because this is my reference angle also, and they are equal. Okay, so how do we find it? Well, it's going to be by reference angle, basically by minus 2 pi over 3, 180 minus 120. So if you multiply by 3, that's going to be pi over 3. Now I'll go here and say, okay, theta equal pi plus pi over 3, which is equal, if you multiply by 3, that's going to be 4 pi over 3. So where are my solutions? So this is one solution in quadrant 3. This is my second solution in quadrant 2. Is this a solution? No. If you try to put cosine 1 pi over 3, you will get 1/2, not -1/2. This is only a reference angle in quadrant 1. And cosine in quadrant 1 is positive. So that's not a solution. So this is not going to be a solution. It's only a reference angle. So my solution, 2 pi over 3 and 4 pi over 3. And if you want an infinite number of solutions, if we are asking you over the domain, we'll say 2 pi over 3 plus or minus 2 pi n, 4 pi over 3 plus or minus 2 pi n. Now, what about cotangent theta plus 5 equal 12? You are going to move the 5 and cotangent theta will be 7. Now you can take cotangent inverse for both sides, but you don't have cotangent on your calculator. So instead, we know that cotangent is 1 over tangent, the reciprocal of tangent. So you can take the reciprocal of both. If you flip both, you will get 1 over cotangent equal 1 over 7. And 1 over cotangent is basically tangent. Now you can take tangent inverse. So theta is equal tangent inverse 1 over 7. If you use the calculator here, you are going to get a decimal answer in radian, of course. So 0.14 radian. 0.14 is actually an angle between, we need to know whether this is a reference angle or not. Reference angle should be an angle between 0 and pi over 2, 90 degrees. Now this is a radian. So what is pi over 2 in decimals? Pi over 2 in decimals. So pi is 3.14. Divide by 2. This is basically equal to 1.57 radian. And I have 0.14. So is 0.14 considered between 0 and 1.57? Yes. So this is a reference angle. because it's an angle less than pi over 2. And pi here we used 3.14. Okay, so we know that this is a reference angle. So let's now think about it. When tangent is positive, 1/7 is positive. Well, tangent is positive in two places. In quadrant 1 and in quadrant 3. So theta in quadrant 1 and theta in quadrant 3. Now in quadrant 1 is going to be an acute angle, so that's a reference angle itself, so it's going to be 0.14 radian. Here in quadrant, this is going to be, if this is 0.14 as a reference angle, this is going to be 0.4 as well, 14 point. Okay, so theta will be equal pi plus 0.14, and pi here is going to be 3.14. That's going to be equal to, if you add them, will be 3.28 radian. So my solution will be 0.14 radian. You have to write the word radian. In the previous ones we used pi, so we don't need to write radian. 0.28 radian. Now if we are looking at an infinite number of solutions, so we'll add 0.14 plus or minus pi n, not 2 pi, because the length of the period in the tangent is pi, not 2 pi. 3.28 plus or minus n pi, by n. Okay? Now, what about this question here? Cosine theta equals sine theta. Well, if you try to take cosine inverse, then you will have cosine inverse of sine, or maybe sine inverse. That's not going to work. However, on the other side, I could divide both sides by cosine theta. And when I do that, cosine theta divided by cosine theta is 1. Sine divided by cosine is tangent theta. Now I can take tangent inverse for both sides. So theta equal tangent inverse of 1, and that's going to be equal, by using the calculator, pi over 4. Now this is pi over 4 is 45 degrees. That's in quadrant 1. I need to ask myself when tangent is positive. Tangent is positive in quadrant 1 and quadrant 3. Now quadrant 1 is we already found it, it's here, so theta equal pi over 4. Quadrant 3, let's say pi plus pi over 4, and again you can make it like denominator, that's going to be 5 pi over 4. So my solution set, pi over 4 and 5 pi over 4. Of course, if you are looking for an infinite number of solutions, you will add or subtract by n, add or subtract by n. Now, how do you check your answer? If you go here and say tangent pi over 4, you should get 1. Tangent 5 pi over 4, you should get 1. Secant 3 theta over 2 equal negative square root of 2. First of all, I don't have theta, I have 3 theta over 2. So I'm not going to have two solutions, I might have more. So now I will ask you this question. If I take secant inverse of both sides, I don't have any of the calculator secant inverse. However, we know that secant of a theta equal the reciprocal of cosine. So if you take a reciprocal of both, here's 1, take a reciprocal of both, that will be cosine 3 theta over 2 is going to be equal negative 1 over square root of 2. Now we can take cosine inverse of both sides, so 3 theta over 2 will be cosine inverse of negative 1 over square root of 2. And that's basically equal to 3 pi over 4. 3 pi over 4, which is about, which is basically in degrees 135 degree. Now I'm just making it in degrees just to help you understand it. That's going to quadrant 2. Now you need to ask yourself, when cosine is negative? Well, we know cosine is negative in 2 quadrants. In a quadrant 2 and in a quadrant 3. So an angle in a quadrant 2, we are talking about this angle here. An angle in a quadrant 3, we are talking about this angle. Now, 3 pi over 4 is an angle in a quadrant 2. So that's going to be my first angle, but it's not theta, it's a 3 theta over 2. Now if you multiply both sides by 2 over 3, this is going to spread out of the coefficient of theta, and that's going to be equal to pi over 2. And this is an angle between 0 to 2 pi. That's 190 degree, by the way. So that's my first angle. Going on to this one, 3 theta over 2 equal, I need to know the reference angle. Because 3 theta over 2, my angle will be equal to pi plus the reference angle. So the reference angle is basically this one here. Let's calculate it. So reference angle will be equal to pi minus 3 pi over 4, which is going to be pi over 4. So that's going to be here. I'm going to erase this and put pi over 4, which is equal 5 pi over 4. Now I can multiply both sides by 2 over 3. So theta will be equal to 5 pi over 6. And again, 5 pi over 6 is basically 150 degrees. So it's still an angle between 0 to 2 pi. Now I need to find the other angles. So I might have more than 2 because I am not calculating theta. I'm calculating 3 theta over 2. I'm going to erase this part. We just put these solution set here. So I have pi over 2. I have 5 pi over 6. Let's see if we are going to get more. I do have 3 theta over 2 equal 3 pi over 4. And 3 theta over 2 equal to 5 pi over 4. So in order to get the next, I'm going to add 2 pi for each one of these. So let's do the calculation now. So I need 4 here, so I'm gonna multiply by 4. So 8 plus 3 11 pi over 4, and then you will multiply everything by 2 over 3. So that's 11 pi over 6. 11 pi over 6 is basically 330 degree, which is at an angle between 0 to 2 pi. So that's, we are going to take it. So I'm going to add it here. Now finally, I'm going to add, again I need 4 here, so you are going to multiply by 4. 8 plus 5 is 13 pi over 4. And then you will multiply everything by 2 over 3. Be 13 pi over 6. And 13 pi over 6 is actually 390 degree. So it does not belong to 0 and 2 pi. It's greater than 2 pi. So we're not going to take this solution. So I do have only 3 solutions. Pi over 2, 5 pi over 6, and 11 pi over 6. Now what about this question here? Well, again, we will take cosine inverse for both sides, and that's going to be 2 theta minus pi over 2 equal cosine inverse square root of 2 over 2. Now we can do this in the calculator, and that's going to give us pi over 4. This is 45 degree angle, and it is in a quadrant 1. Now we need to ask ourselves when cosine is positive. Well, cosine is positive in quadrant 1 and 4. So an angle in quadrant 1 is going to be the same one here. So we'll say not theta, we'll say 2 theta. So we're going to say 2 theta minus pi over 2 equal pi over 4. And here we need this part, which is the reference angle, and it's basically the same as pi over 4. So 2 theta minus pi over 2 equal 2 pi minus pi over 4. And now we can do the calculation. So that's going to be 2 theta. You can multiply here by 2. That's going to be 2. That's going to be 4. So 2 theta equal 3 pi over 4. And then you divide both sides by 2. So theta will be equal 3 pi over 8. 3 pi over 8 is basically 67.5 degrees, and it is an angle in quadrant 1. Now next we'll do this one here. So 2 theta minus pi over 2 equal 7 pi over 4. Then 2 theta equals 7 pi over 4 plus pi over 2. 2 theta equal 9 pi over 4, and then you divide both sides by 2. So theta will be equal 9 pi over 8. And 9 pi over 8 is basically 202.5 degrees, which is again an angle between 0 to 2 pi. Now so far we have two solutions, 3 pi over 8 and 9 pi over 8. So if I will go here, I'm going to say solution set is 3 pi over 8, 9 pi over 8. Now let's see if we are going to find more solutions. Well, I could add 2 pi because I'm not asking for theta, I'm asking for 2 theta minus pi over 2. So I'm going to add 2 pi each time. So I'm going to say 2 theta minus pi over 2 equal pi over 4 plus 2 pi. And here I can say 2 theta minus pi over 2 equal 7 pi over 4 plus 2 pi. Now we can solve it. So I'm going to do this part first. Eleven pi over 8, and 11 pi over 8 is basically 247.5 degrees, and that's actually an angle from 0 to 2 pi. So we are going to add this angle here. Now on this side, 2 theta minus pi over 2 equal 15 pi over 4. And then you divide both sides by 2. Seventeen pi over 8 is basically 382.5. This is not between 0 and 2 pi. So we are not gonna take this angle. So that's everything. Okay. So guys, let me know if you have any question, and see you next time. Bye bye.